Out there, past the gas giants and the rings of Saturn, lies a world of icy mystery. Triton, a captive moon in Neptune's grasp, beckons. Could this frozen sphere hold the key to humanity's future? Could we, with our ingenuity and will, transform this alien landscape into a new home? The idea seems audacious, even impossible. But what if it's not? What if terraforming Triton, making it suitable for human life, is within our reach? The quest for a second home for humanity has taken us across the solar system, from the scorched plains of Mars to the sulfurous volcanoes of Io. Yet, Triton stands out, a beacon in the darkness. Why Triton? Why not the closer, seemingly more hospitable worlds? The answer lies in Triton's unique composition, its potential to harbor the building blocks of life, and its tantalizing proximity to the outer reaches of our solar system. Triton is a world of stark contrasts. Its nitrogen geysers erupt with surprising force, hinting at a hidden internal heat. Vast plains of nitrogen ice stretch towards the horizon, broken by rugged ridges of unknown composition. And beneath it all, a possible ocean of liquid water, a tantalizing promise of life's essential ingredient. Triton is a world of secrets waiting to be unlocked. The challenges are immense, no doubt, but the potential rewards are even greater. Imagine a terraformed Triton, a world reborn with oceans teeming with life, with skies painted with the colors of a new dawn. A world where humanity can thrive, not just survive, amongst the stars. This is the vision, the dream that drives us to explore the possibilities, to ask the question, can we terraform Triton? Triton is a world of contradictions, a celestial body that defies simple categorization. It's the largest moon of Neptune, a giant among the many moons that orbit the distant planet, a behemoth of rock and ice, with a surface that tells a story of both violence and tranquility. Yet it orbits its planet in the opposite direction of Neptune's rotation, a phenomenon known as a retrograde orbit. This retrograde orbit, unique among large moons in our solar system, suggests a violent past, a history marked by dramatic events. A story of capture and cosmic upheaval, where Triton was not always a moon of Neptune. Billions of years ago, Triton likely formed in the Kuiper Belt, a distant region of icy bodies beyond Neptune. This region, filled with ancient remnants of the solar system's formation, was Triton's original home. Gravitational interactions with other objects may have flung Triton inwards, towards the giant planet, setting the stage for its capture. Neptune's gravity captured Triton, but not without a struggle, a cosmic dance that left its mark on the moon. The gravitational forces at play heated Triton's interior, melting ice and triggering intense geological activity, reshaping its surface. Today, Triton is a frozen world, a stark contrast to its tumultuous past. Its surface chilled to a frigid -391 degrees Fahrenheit, or -235 degrees Celsius, making it one of the coldest places in the solar system. The thin atmosphere, composed mainly of nitrogen with traces of methane, offers little protection from the harshness of space, creating an environment of extreme conditions. Yet, Triton is far from dead, its surface still active and dynamic. The nitrogen geysers, erupting from beneath the surface, are a testament to the moon's internal heat, a sign of ongoing geological processes. These geysers, along with the cantaloupe-like terrain, suggest a dynamic world with a complex geological history, one that continues to evolve. Triton's surface is a canvas of diverse landscapes, each telling a different part of its story. Vast nitrogen ice plains, smooth and featureless, dominate much of the moon, creating a stark alien landscape. These plains are punctuated by cryovolcanoes, icy counterparts to Earth's volcanoes, which erupt with plumes of nitrogen, methane, and other volatiles, adding to the moon's dynamic nature. Cantaloupe terrain, named for its resemblance to the fruit's skin, covers other areas, its origin still debated among scientists. This terrain, with its mysterious formation, continues to intrigue and puzzle researchers. This frozen world, with its retrograde orbit and enigmatic features, holds clues to the early solar system and the processes that shaped the icy giants and their moons, offering a window into the past. But Triton is more than just a relic of the past. It represents a potential future for humanity. It's a potential future home for humanity, a world ripe for transformation and exploration, a world ripe for transformation, where the harsh conditions could one day be tamed, and Triton could become a new frontier for human exploration and settlement. The 22nd century dawns on a world grappling with the consequences of its past. The rapid advancements in technology have brought us to a pivotal moment in human history. Earth, our cradle, our only home, groans under the weight of an ever-growing population. Cities swell beyond their limits, and the strain on our planet becomes ever more apparent. Resources dwindle, climate change tightens its grip, and the delicate balance of our biosphere teeters on the brink. The environmental crises we face are not just local but global, affecting every corner of our world. The need for a solution, a way to ensure humanity's survival, has never been more urgent. Scientists and visionaries are working tirelessly to find answers, to chart a course for our future. Space colonization, once a distant dream, is now a necessity. The idea of establishing human settlements beyond Earth is no longer science fiction, but a tangible goal. We must look beyond the familiar blue sky, beyond the confines of our home planet, to the vastness of space for salvation. The cosmos offers us a chance to start anew, to build a future unburdened by the mistakes of the past. The stars, once distant and unattainable, now beckon us with the promise of a new beginning. They hold the potential for new worlds, new opportunities, and new hope. But why venture so far? Why take such a monumental leap into the unknown? Why not focus our efforts on Mars, our planetary neighbor? Mars, with its proximity and similarities to Earth, seems like a logical first step. While Mars holds promise, it presents its own set of challenges. Its harsh environment and thin atmosphere make it a formidable frontier. Its thin atmosphere, lack of a global magnetic field, and limited water resources make terraforming a monumental task. The challenges are significant, but so are the potential rewards. Triton, on the other hand, offers a unique set of advantages. This distant moon of Neptune presents opportunities that are worth exploring. Triton's nitrogen-rich atmosphere, while thin, provides a starting point for creating a breathable atmosphere. This could be the foundation for a new human habitat. Its potential subsurface ocean could hold vast reserves of water, essential for life as we know it. Water is the key to sustaining any colony, and Triton may have it in abundance. And its location in the outer solar system, while distant, offers access to resources and energy sources that could fuel a thriving civilization. The outer solar system is rich in materials that could support human life. The challenges of colonizing Triton are immense, but so are the rewards. The potential for scientific discovery and human advancement is unparalleled. It's a gamble, a leap of faith into the unknown. But history has shown that humanity thrives on challenges, on pushing the boundaries of what is possible. But it's a gamble we must take if we are to ensure the survival of our species. The future of humanity depends on our willingness to explore, to innovate, and to take risks. The time for hesitation is over. The challenges we face on Earth demand bold action and visionary thinking. The future of humanity lies among the stars, and Triton may hold the key to unlocking that future. Our destiny is in the cosmos, and the time to act is now. Section 4. Breathing life. Engineering a habitable atmosphere. Transforming Triton from a frigid, airless world to a habitable haven for humanity will require nothing short of a technological revolution. This ambitious endeavor will push the boundaries of our current scientific understanding and engineering capabilities. The first and most crucial step, crafting a breathable atmosphere. Without this, no other terraforming efforts can succeed. The thin nitrogen shroud that currently envelops Triton is a far cry from the life-sustaining air we breathe on Earth. This presents a significant challenge, but also an opportunity for innovation. The process begins with warming the planet. This is essential to kickstart the transformation. Giant orbital mirrors, positioned to reflect the distant sun's rays onto Triton's surface, could raise temperatures enough to trigger a runaway greenhouse effect. This method harnesses the power of the sun to initiate a chain reaction. As the ice melts, releasing trapped greenhouse gases, the atmosphere will thicken, trapping more heat and further accelerating the process. This self-sustaining cycle is crucial for long-term atmospheric development. But simply having a thicker atmosphere isn't enough. We need to ensure it can support human life. We need to adjust its composition, introducing the right mix of gases to support human life. This involves precise scientific calculations and continuous monitoring. Advanced nanotechnology could be employed to break down Triton's abundant nitrogen into oxygen, a process similar to what plants do on Earth. This technology mimics natural processes on a grand scale. Genetically engineered extremophile bacteria, capable of surviving in harsh conditions, could be introduced to further modify the atmosphere and create a more Earth-like environment. These microorganisms would play a pivotal role in the transformation. The transformation won't happen overnight. It requires patience and persistence. It will be a gradual process, spanning decades, even centuries. Each phase will bring us closer to our goal. But with each passing year, Triton's atmosphere will grow thicker, warmer, and richer in oxygen. This incremental progress is a testament to human determination. The skies will transition from a hazy pink to a vibrant blue, a testament to the power of human ingenuity. This visual change will symbolize our success. The creation of a breathable atmosphere is just the first step in a long and arduous journey. It sets the foundation for all future efforts, but it's a crucial step, one that will pave the way for the next stages of terraforming Triton. Each milestone achieved will bring us closer to making Triton a new home for humanity. With each breath of fresh, Triton-made air, we'll be one step closer to making this alien world our own. This vision of the future drives our efforts and fuels our dreams. Section 5. The heart of an ice giant harnessing Triton's energy. Terraforming a world requires more than just a breathable atmosphere. It demands a reliable and sustainable source of energy to power the transformation and sustain a burgeoning civilization. Fortunately, Triton, despite its frigid exterior, harbors a hidden furnace within its icy heart. Triton's internal heat, evidenced by its active geology and nitrogen geysers, is a potential gold mine for energy production. Deep geothermal plants, drilled into the moon's crust, could tap into this heat, converting it into electricity to power homes, industries, and the very terraforming efforts themselves. But Triton's energy potential extends beyond its core. The vast plains of nitrogen ice, when exposed to sunlight, could be utilized to create massive solar farms. These farms, equipped with advanced photovoltaic cells, would convert sunlight into electricity, providing a clean and renewable energy source. The combination of geothermal and solar power could create a robust and sustainable energy grid for a thriving Triton colony. Excess energy could even be beamed back to Earth, helping to alleviate our home planet's own energy demands. Harnessing Triton's energy resources will be a monumental task, requiring innovative engineering and a deep understanding of the moon's internal structure, but the rewards are well worth the effort. A self-sufficient Triton, powered by its own internal and external resources, would be a beacon of hope for humanity, a testament to our ability to thrive in even the most challenging of environments. Neptune, the eighth planet from our Sun, holds a captivating secret. This distant world, with its deep blue atmosphere and swirling storms, has always intrigued astronomers and space enthusiasts alike. It's a moon called Triton, a mysterious and icy satellite that orbits Neptune in a retrograde direction, meaning it moves opposite to Neptune's rotation. This icy world has fascinated astronomers for decades. Triton's surface is a frozen wonderland, covered in nitrogen ice, and its unique characteristics have made it a subject of intense study. Triton is unique in many ways. Unlike most moons in our solar system, it is believed to have been captured by Neptune's gravity, rather than forming in place. It's not just another celestial object. Triton's retrograde orbit and geologically active surface set it apart from other moons. Scientists believe it might hold the key to answering one of humanity's biggest questions. Are we alone in the universe? The potential for life on Triton is a tantalizing possibility. Triton is a world of extremes. Its surface is a harsh frozen landscape, with temperatures that challenge the limits of what we understand about planetary environments. It's incredibly cold, with surface temperatures plummeting to -391 degrees Fahrenheit. This makes Triton one of the coldest objects in our solar system. It's also geologically active, with geysers erupting from its icy surface. These geysers are a sign of internal heat, which could mean there is more to Triton than meets the eye. These geysers hint at a hidden ocean beneath the surface, an ocean that could be kept liquid by the heat generated from tidal forces as Triton orbits Neptune. This ocean could potentially harbor life. The idea that microbial life could exist in such an extreme environment is both thrilling and revolutionary. The possibility of finding life on Triton is incredibly exciting. It would be a monumental discovery, reshaping our understanding of where life can exist. It would change everything we thought we knew about the solar system. The discovery of life on Triton would open up new avenues of exploration and scientific inquiry. Imagine discovering that life exists not just on Earth, but on a moon orbiting a distant gas giant. It would expand our horizons and redefine our place in the universe. It would be a paradigm shift for science and our understanding of our place in the cosmos. the search for life on Triton continues to inspire and drive the quest for knowledge in the vast expanse of space. In 2131, humanity embarked on a daring mission to Triton, Neptune's largest moon. The Triton Explorer, a marvel of engineering and human ingenuity, was launched into the vast expanse of space, carrying with it the hopes and dreams of countless scientists and explorers. Its mission was clear and ambitious: to unlock the secrets hidden beneath Triton's icy shell, secrets that had eluded humanity for centuries. The journey was long and fraught with challenges, from navigating through cosmic debris to enduring the harsh conditions of deep space. But the Triton Explorer persevered, finally reaching its destination in 2135, a testament to human determination and technological prowess. Upon arrival, the Triton Explorer immediately began its work, deploying a suite of advanced instruments designed to probe the moon's mysteries. These instruments included high-resolution cameras capable of capturing the moon's surface in stunning detail, spectrometers to analyze its composition, and even a small lander designed to penetrate the icy surface and explore the hidden depths below. The data started pouring in, revealing a world stranger and more wondrous than anyone had imagined. A world that defied our expectations and expanded our understanding of the cosmos. The mission's findings were nothing short of groundbreaking, providing new insights into the nature of Triton and its potential for harboring life. The Triton Explorer confirmed the presence of a subsurface ocean, a vast body of water hidden beneath the icy crust, teeming with possibilities. It also detected complex organic molecules, the building blocks of life as we know it, suggesting that Triton could potentially support life. These discoveries sent shockwaves through the scientific community, sparking excitement and debate about the implications for our understanding of life in the universe. The Triton Explorer mission represents a pivotal moment in our exploration of the solar system, a moment that will be remembered for generations to come. It has opened our eyes to the possibility of finding life in the most unexpected places, challenging our assumptions and inspiring new questions. Triton, once considered a cold and barren world, is now a prime candidate in the search for extraterrestrial life, a beacon of hope in our quest to understand the universe and our place within it. Triton's atmosphere is thin, a wisp compared to the blanket of air we have on Earth. This thin veil is barely enough to be called an atmosphere, yet it holds many secrets. It's composed mainly of nitrogen, which is the most abundant gas, making up the majority of this tenuous layer. Alongside nitrogen, there are traces of methane and carbon monoxide. These minor components, though present in small amounts, play a significant role in the atmospheric dynamics. These trace elements are particularly intriguing. They suggest ongoing chemical reactions and interactions within the atmosphere. They hint at geological processes happening beneath the surface. The presence of these gases could be a sign of active geology, reshaping the moon's surface over time. Could these processes be related to the geysers observed erupting from Triton's south polar region? These geysers are a spectacular sight, shooting plumes of material high into the thin atmosphere. The Triton Explorer made some remarkable discoveries about Triton's atmosphere. Its instruments provided detailed data, revealing the dynamic nature of this thin layer. It found that the atmosphere is constantly being replenished. This continuous renewal is crucial for maintaining even a thin atmosphere in the harsh environment of space. This replenishment likely comes from the geysers and possibly even from the subsurface ocean. The interaction between these sources and the atmosphere is a subject of ongoing research. The interaction between the atmosphere and the surface is complex and fascinating. It involves a delicate balance of physical and chemical processes. Scientists believe that Triton's atmosphere might hold clues to the composition of its subsurface ocean. By analyzing the gases present, they can infer the types of materials and conditions below the icy crust. By studying the atmosphere, we can learn about the ocean without even having to drill through the ice. This non-invasive method is a powerful tool for planetary science. This is a powerful tool in our quest to understand the potential habitability of this icy moon. Triton's thin atmosphere, though fragile, holds the key to many mysteries beneath its surface. Triton's geysers are a spectacular sight. They erupt from the moon's south polar region, spewing nitrogen gas and dark, dusty material high into the thin atmosphere. These geysers are a testament to the geological activity happening beneath Triton's icy shell. They provide a glimpse into the moon's hidden interior. The Triton explorer observed these geysers in detail. It found that they can reach heights of up to 5 miles. The dark material ejected by the geysers is thought to be organic compounds. These compounds are carried upwards from the subsurface ocean by the erupting nitrogen. The presence of geysers on Triton is incredibly significant. They suggest that Triton is not a dead world but an active one. The geysers also provide a potential mechanism for material from the subsurface ocean to reach the surface. This material could then be analyzed for signs of life. Section 5. An unexpected dance. The mystery of Triton's orbit. Triton has a peculiar orbit. Unlike most moons in the solar system, which orbit their planets in the same direction as the planet's rotation, Triton orbits Neptune in the opposite direction. This is called a retrograde orbit. It's a strong indication that Triton is not a native moon of Neptune. Scientists believe that Triton was once a dwarf planet. It was captured by Neptune's gravity billions of years ago. This capture event would explain Triton's unusual orbit. It would also explain the moon's internal heating, which is thought to be responsible for its geological activity. The capture of Triton by Neptune would have been a cataclysmic event. It would have had a profound impact on both bodies. Understanding this event is crucial to understanding the evolution of Triton and its potential for harboring life. Section 6. A hidden ocean beneath the frozen surface. One of the most exciting discoveries made by the Triton explorer was the confirmation of a subsurface ocean. This ocean lies beneath Triton's icy shell, hidden from view. Scientists believe it could be one of the largest oceans in the solar system, larger even than Earth's oceans. The ocean is thought to be composed of water and ammonia. This mixture would remain liquid even at Triton's frigid temperatures. The ocean is also thought to be salty, perhaps even saltier than Earth's oceans. This salinity would further lower the freezing point of the water. The presence of a subsurface ocean on Triton is incredibly significant. It raises the tantalizing possibility that life could exist in this hidden realm. Protected from the harsh conditions on the surface, life could flourish in the depths of Triton's ocean. Section 7. The chemistry of life, organic molecules on Triton. The Triton explorer detected complex organic molecules on Triton's surface. These molecules, the building blocks of life as we know it, were found in the dark material ejected by the moon's geysers. This discovery has fueled speculation that life might exist on Triton. The organic molecules detected on Triton are similar to those found on comets and in the interstellar medium. This suggests that the building blocks of life are common throughout the universe. It also raises the possibility that life on Triton, if it exists, could be similar to life on Earth. The discovery of organic molecules on Triton is a major step forward in our search for extraterrestrial life. It shows that the ingredients for life are present in this distant world. The next step is to determine whether these ingredients have actually given rise to life. Section 8. A past transformed. Could Triton have once supported life? Triton's unusual orbit and internal heating suggest that it might have had a very different past. Some scientists believe that Triton was once much warmer than it is today. It might have even had a thicker atmosphere and liquid water on its surface. If Triton was once warmer and wetter, it's possible that life could have arisen on its surface. This life could have then retreated to the subsurface ocean as Triton cooled down. The subsurface ocean would have provided a stable environment for life to survive, even as conditions on the surface became uninhabitable. While we don't have definitive proof that Triton was once habitable, the possibility is intriguing. It highlights the dynamic nature of celestial bodies and the potential for life to exist in unexpected places. Section 9. A new frontier, Triton's place in the search for life. The discoveries made by the Triton explorer have revolutionized our understanding of this distant moon. Triton is no longer seen as a cold and barren world. It's now considered a prime candidate in the search for extraterrestrial life. Triton possesses many of the key ingredients for life as we know it. It has a subsurface ocean, organic molecules, and a source of energy from internal heating. While we haven't found definitive proof of life yet, the possibility is tantalizing. Triton is a new frontier in our exploration of the solar system. It's a world full of mysteries waiting to be unlocked. Future missions to Triton will undoubtedly reveal even more about this fascinating moon and its potential for harboring life. Ship, the Odyssey, Pearson managed this precious resource. Neptune, the icy giant, holds a secret. It is a secret cloaked in nitrogen frost and shrouded in mystery, a world so cold and distant it seemed impossible to ever reach, let alone inhabit. This secret is Triton, Neptune's largest moon. A moon that has intrigued scientists and explorers for generations. Once it was a desolate wasteland. A place where no life could thrive, where the environment was as harsh as it was unwelcoming. Temperatures plunged hundreds of degrees below freezing. The cold was so intense that it could freeze any known material in seconds. The surface was a canvas of ice, sculpted by geysers and nitrogen lakes. These natural phenomena created a landscape that was both beautiful and deadly. Only the faintest whispers of possibility, of life, could be imagined. Scientists speculated about the potential for microbial life, hidden beneath the icy crust. Today, Triton is a testament to human ingenuity. What was once a frozen wasteland is now a thriving colony, a beacon of hope and resilience. We have transformed this icy world into a beacon of human life. Advanced technology and relentless determination have turned dreams into reality. Gleaming habitats dot the landscape. These structures are marvels of engineering, designed to withstand the extreme conditions of Triton. The air hums with the activity of settlers. Scientists, engineers, and explorers work tirelessly to ensure the colony's success. Triton stands as a symbol of our potential, a testament to the boundless spirit of exploration that burns within us. It represents what humanity can achieve when we dare to dream big. But how did we achieve this remarkable feat? How did we turn an inhospitable moon into a thriving community? How did we transform this frigid alien moon into a home away from home? The journey was long and arduous, filled with countless challenges and obstacles. The journey began with a dream, a vision of reaching beyond the familiar comforts of Earth. Visionaries and pioneers imagined a future where humanity could thrive on other worlds. It was a dream fueled by a thirst for knowledge and a desire to push the boundaries of human achievement. Scientists and engineers worked tirelessly, developing the technology needed to make this dream a reality. The journey to Triton was fraught with challenges, each more daunting than the last. From the vast distances of space to the harsh conditions of the moon, every step was a test of our resolve. Yet, we persevered, driven by the same spirit of innovation that has always defined our species. We faced each challenge head-on, finding solutions and making progress one step at a time. We faced the impossible and brick by cosmic brick, built a new world. Triton is now a thriving colony, a testament to what we can achieve when we work together towards a common goal. Families now call Triton home. Children play under the protective domes, and life flourishes in a place once deemed uninhabitable. Advanced agricultural techniques have allowed us to grow food in Triton's alien soil. We have created a self-sustaining ecosystem, ensuring the colony's long-term survival. Medical facilities provide top-notch healthcare, utilizing the latest advancements in technology. The well-being of the settlers is a top priority. Educational institutions ensure that the next generation is well prepared to continue the legacy of exploration and innovation. Children learn in futuristic classrooms, inspired by the achievements of their predecessors. As night falls, the colony glows under the stars. Triton, once a frozen wasteland, now stands as a shining example of human potential and the unyielding spirit of exploration. Triton's thin atmosphere posed the first hurdle. Unlike Earth, which has a thick protective blanket of gases, Triton's atmosphere was barely there, a mere wisp of nitrogen and methane. This thin veil offered no protection from the harsh radiation of space. The sun's rays, unfiltered and unforgiving, bombarded the surface, making it inhospitable for any form of life as we know it. To make Triton habitable, we needed to create a breathable atmosphere, a shield against the elements. This was no small feat. We had to think beyond conventional methods, pushing the boundaries of science and technology. Our scientists turned to the stars themselves for inspiration. The vast expanse of the universe held secrets and solutions that we could harness. By studying the natural processes of other celestial bodies, we began to formulate a plan. Giant orbital mirrors, strategically positioned around Triton, captured and redirected the sun's energy. These mirrors were marvels of engineering, designed to withstand the harsh conditions of space while focusing sunlight precisely where it was needed. This focused energy powered massive atmospheric processors, machines designed to mimic Earth's own natural processes. These processors were the heart of our operation, converting raw materials into life-sustaining gases. These processors worked tirelessly, breaking down Triton's icy surface. The ice, once a barrier to life, became a resource, a source of vital elements. they extracted vital elements like oxygen and nitrogen. These elements, once locked in the ice, were now being released into the atmosphere, slowly transforming Triton into a more Earth-like environment. Slowly but surely, the air grew thicker, richer, and more capable of supporting human life. Each day, the atmosphere became more stable, more breathable, a testament to our relentless efforts. It was a delicate dance, a balancing act of temperature and pressure. We had to ensure that the conditions remained just right, not too hot, not too cold, with the perfect mix of gases. Too much change, too quickly, could have catastrophic consequences. A sudden shift in temperature or pressure could undo all our hard work, making the environment unstable and dangerous. But our engineers and scientists persevered, their efforts a testament to human ingenuity and our unwavering determination to make Triton our new home. They worked day and night, overcoming countless challenges, driven by the vision of a new world where humanity could thrive. With a breathable atmosphere, our attention turned to Triton's frigid heart. This distant moon, orbiting Neptune, held secrets beneath its icy exterior that beckoned us to explore further. The surface temperature, a bone-chilling -391 degrees Fahrenheit, was far too cold to sustain life as we knew it. The harsh, frozen landscape seemed inhospitable, a stark contrast to the warmth and vitality we sought to bring. We needed to find a way to warm the moon, to thaw the ice and awaken this sleeping giant. Our mission was clear: to transform Triton from a frozen wasteland into a habitable environment. This required innovative thinking and cutting-edge technology. The answer lay beneath our feet, deep within Triton's core. The moon's interior held untapped potential, a geothermal heart that could be harnessed to bring warmth to the surface. This hidden energy source was our beacon of hope. Geothermal energy, the heat generated by the moon's interior, held the key. By tapping into this natural resource, we could initiate a process of gradual warming, turning the icy plains into a more temperate environment. We developed advanced drilling techniques, utilizing nanobots to penetrate the moon's crust with minimal disruption. These tiny yet powerful machines were designed to withstand the extreme conditions and reach the geothermal reservoirs deep below. These intricate networks of underground tunnels tapped into the immense heat reserves. The tunnels were meticulously planned and constructed, ensuring that the geothermal energy could be efficiently extracted and distributed. Geothermal plants, humming with power, converted this energy into usable heat, gradually warming the moon's surface. These plants were marvels of engineering, designed to operate seamlessly in the harsh environment of Triton. The icy plains began to thaw, and the first hints of liquid water, the lifeblood of our planet, emerged. This transformation marked the beginning of a new era for Triton, a testament to human ingenuity and perseverance. The once desolate moon was now on a path to becoming a thriving, habitable world. Section 4. Beneath the ice, unlocking Triton's hidden oceans. Water, the elixir of life, was not only found on the surface. Deep beneath the icy shell, Triton harbored vast hidden oceans. These subterranean bodies of water, shielded from the cold void of space, held immense potential for sustaining a human colony. We deployed autonomous underwater vehicles, marvels of engineering equipped with powerful lasers and sonic drills. These robotic pioneers carved through the ice, creating pathways to the hidden oceans below. The discovery of these oceans was a turning point. They provided a source of water for drinking, irrigation, and even energy. They also revealed a treasure trove of aquatic life, offering a glimpse into the potential for biodiversity beyond Earth. Section 5. The art of growing in ice hydroponics and bioengineered foods. Food, the sustenance of life, presented its own unique challenge. Triton's frozen surface was far from ideal for traditional agriculture. We needed to find innovative ways to cultivate crops in this harsh, unforgiving environment. The solution lay in a combination of hydroponics and bioengineering. We constructed massive, climate-controlled greenhouses, bathed in the warm glow of artificial sunlight. Inside, plants grew not in soil but in nutrient-rich water solutions, their roots suspended in a carefully calibrated blend of essential minerals. Our understanding of genetics had also advanced by leaps and bounds. We engineered crops specifically adapted to Triton's environment. These plants thrived in lower light conditions, tolerated the unique mineral composition of Triton's water, and even possessed enhanced nutritional value.